Okay, we're going to move on to the next step in terms of summations. And what I'd like to do is I'd like to pose a problem to you. What if instead of trying to sum up 1 through 4, we wanted to just sum up 3 through 4? So we've looked at a problem that looks like this, which again is the bowling alley problem. Just have 1 plus 2 plus 3 plus 4. But what happens if I do this? What if I want to do 3 to 4? I just want to do the third and fourth rows. Now, we know common sense would tell us this is 7, but is there an easy way to figure this out? And so this is going to require a little bit more algebra, but I do want to show you that this can be modeled in the same way with Legos, and hopefully it'll make a lot of sense by the time we're done. Okay? So one way to think about this is that this is just this minus this. Okay? If I'm trying to figure out what 3 plus 4 is, I'm just taking the summation of 1 through 4 minus the summation of 1 through 2. In other words, this, or excuse me, in summation notation, that's what we're looking at. If I'm trying to figure this out, well, I just need to take this summation, 1 through 4, and I need to subtract out this summation to give me the 3 through 4. And so let's see if we can kind of mess with the algebra here and come up with a simpler way to write it than that. So if you'll remember, we have n times n plus 1 over 2. Because if I'm trying to figure out what 1 through 4 is, I can just take 4 times 5 divided by 2 and get my answer. Okay. And so instead of using n, let's call, just for the sake of this example, let's call 4 the big number. Let's replace it with b. And then let's call 3 the little number. And so this is equal to that, right? And so we're going to take this now. Now, on this one, we're using 2. This is summation from 1 to 2. And so I can't say little number because the little number was 3. So I'm going to have to replace all the places where I would use little number with little number minus 1. Okay? So I'll just use a cursive L minus 1 times L minus 1 plus 1 over 2, because I'm using that same thing. And just so I'm not losing anybody, this is 4 times 5 divided by 2, gives me that, minus 3 minus 1, which is 2, times 3 minus 1 plus 1, which is 3, divided by 2. So I'm left with that minus that equals that. That's how to write it using algebra. And so let's try to simplify this. We have a common denominator here, so we can just do this. Right? And then this guy is a minus 1 plus 1, so we can just get rid of that. And then we can distribute. So we'll be left with b squared plus b. And this will be L squared minus L, but then we have a negative, so minus L squared, and then that would be plus L over 2. And just to make sure that we're still on track, let's actually replace those things. Remember, b equals 4, L equals 3. So we should have 16, which is 4 squared, plus 4, minus 3 squared, 9 plus 3 over 2. And remember that that should equal 7 if we're doing this right. 20 minus 9 would be 11 plus 3, so 20 minus 9 plus 3 is 14, divided by 2 equals 7. So we're on the right track. Okay, now what's kind of cool about this is that we can pull out a factor of the interval. And that sounds absolutely crazy. But let me show you what I'm talking about. B minus L plus 1. If I want to figure out how many rows I have, right? This would be 1, 2. Then what I can do is I can take 4 minus 3 plus 1. And that would give me 2. Let's say that I wanted to figure out what the summation from I equals 2 to 4 would be. Well, I could take 4 minus 2 plus 1, and that'd be 3. And that's absolutely right, because if I'm doing 2 to 4, I do have 3 rows here. I do have 3 intervals here. Big minus little, 4 minus 2 plus 1, will always give me the number of rows I have. If I wanted to figure out what the intervals I had from 1 to 4 were, I know that that's 4, right? 1, 2, 3, 4. I could take 4 minus 1, actually, 3 plus 1 is 4. So this is just another way of saying the number of intervals I have, the number of rows I have. So what this does is it allows me to pull that out of this. I can pull that out using some nifty algebra, and I'm left with this as my leftover expression. And just to check my work, I'm sorry, that's L. B squared there plus BL minus BL minus L squared plus B plus L. Plus BL will cancel with minus BL, and I'll be left with B squared plus B minus L squared plus L, which is the exact same thing that I had wherever it was up here. All right. So what I'm left with is if I just replace this expression with, we'll call it I for interval, then I have the interval times B plus L over 2. And that will give me the summation from some little number to some big number. Okay? And that might sound crazy, but this is absolutely right. If you think about adding up 3 through 4, well, we can just take 3 plus 4, or 4 plus 3, times the number of intervals there are, and we know that there'd be 2 rows in a bowling alley if I had 3 and 4, right? So times 2 divided by 2 equals 7. We knew that was the answer, right, from earlier. So what would I have if I had 2 through 4, right? I know there are 10 pins in a bowling alley, so I get rid of 1. I'm going to have 9. So let's see if this equation works. I have the big, which is 4, plus the little, times the number of rows, 1, 2, 3, over 2. 3 times 6 is 18, divided by 2 is 9. Now, here's the way that I'd like you to think about this in terms of Legos. If I'm trying to figure out what 3 to 4 is, well, what if I just did 2 of them like that? it's taking my intervals, how many intervals I had, times 3 plus 4 divided by 2. Works the exact same as the last one. Let's say I wanted to figure out what my interval, or what my summation was from 2 to 4. Well, I take the number of intervals I have, 1, 2, 3, times 2 plus 4, which is 6, right, divided by 2. We went the long way here. I mean, this is all the algebra to prove it. We distributed, we pulled things out, we did lots of interesting stuff, but this is really what it boils down to. Is that even when you get rid of the 1, right, you can still make a shape with it. And this would work for, you know, some crazy ones. If I wanted to do the summation from 150 to 260. What's 150 plus 151 plus 152 all the way to 260? Well, just take the big, 260, plus the little, 150, times the number of rows that there'd be. And how do you figure out the rows? I mean, you could just subtract, right? So 260 minus 150 would be 110, right? But you have to add an extra one to make it work. And we figured that out down here. So b minus l plus 1. So it'd be 110 plus 1 is 111. So, and all that divided by 2. And that'd be your answer. And the reason is, if you had a big enough set here, you'd have 150 lined up here, 260 lined up here, and all the ones in between. And when you lined it up, it'd be 150 plus 260 times however many intervals you had, which would be 111 different rows there. Okay. If you don't remember the b minus l plus 1, remember if I'm trying to figure out what 3 to 4 is, well, 4 minus 3 plus 1 is 2, and that's correct. I have 2 rows here. I'm trying to figure out how many rows there are with 2 to 4. 4 minus 2 plus 1 is 3. 1, 2, 3. I'm trying to figure out how many rows there are with 1 through 4. 4 minus 1 is 3, plus 1 is 4. That's the way it works. Okay. So this equation is another one that I think a lot of students have a hard time remembering or understanding or caring about, but it's kind of intuitive if you think about it in terms of this. It works. The number of intervals you have, however many rows, how many rolls of bowling pins you have, times the little plus the big, divided by 2. Okay. I hope this was helpful.